Hi, this is Michael King, and we're going to look at how to value perpetuities using Excel. Notice that this is the formula for the present value of a perpetuity. You have an equal payment starting in the next period, which is divided by the difference between the discount rate, K, and the growth rate of the payment, G. Now, when G equals 0, we have what's known as a fixed or constant perpetuity. And when G is either positive or negative, we have what is known as a growing or shrinking perpetuity. Okay, so it's relatively straightforward. So let's say we have $100 at a discount rate of 5%, and it does not grow, it is the same forever. We're going to put a formula starting with equal sign, $100 divided by the difference between K minus the growth rate G. Close brackets, and we see that it is $2,000. So what would happen if this perpetuity was to grow each period by 2%? We would start with $100. The discount rate is going to be 5%, and our growth rate is going to be 2%. Using the equal sign, payment divided by, open brackets, K minus G, close brackets, and hit enter, and you see that it is $3,333. Notice that for the growing perpetuity, it is worth $1,333 more, which is because the payment is going to increase from $100 to $102, and so on going forward. As a result, the present value is going to be worth more. And we're now going to look at how to use Excel to find the value of an annuity. We're going to look at both the present value and the future value, and we're going to look at two different types of annuities: an ordinary annuity, where the payments come at the end of the period, and an annuity due, where the payments come at the start of the period. Here we are. I've set up the template. The question I'm looking at is, what is the future value of an ordinary annuity that pays $1,000 each year for 3 years, compounded at 6%? So the interest rate is 6%. The number of periods is 3. Here, rather than entering 0, which we did previously with present value, future value, we need to add a payment that we're going to be receiving of $1,000 each year. Now, because we're receiving this payment through the annuity, we're being asked what the future value is, but there is no starting value for this annuity, so the present value is going to be 0. Now, critically, we have to enter the correct type because we want to make sure that we're getting payments at the end of the period. Using the function in Excel, 0 represents end of period and 1 represents start of period, so we're entering 0. Now we can enter the function either by hitting the function button up here or by starting to type it using the formula which you see here, equals FV. And I've got the function, the inputs here described as well as set up one on top of each other. So we're at 6% rate for 3 periods, receiving $1,000 each period with no present value, and the payments are coming at the end of the period. We hit enter, and you see that the future value is going to be $3,183.60. Notice that the value is going to be negative because the payments are positive. If we wanted the future value to be positive, we would have to have a negative number for the payments. This is a specific feature of Excel. Next, we're going to use the actual annuity formula, and this is the formula for an ordinary annuity, finding the future value. Here we're going to enter a formula, so we're going to put equal signs, and we're going to start typing the inputs. It's going to be the payment multiplied, which is in C6, multiplied using the star. And we have to be careful to get the brackets correct because we want to make sure that the order of operations is in the correct order. So we have one bracket for the large square brackets and another bracket for the inside function here. 1 plus the rate of interest, close brackets, raised to the power of 3. Now you see it's minus 1, and I'm going to close brackets here so that this is all calculated before dividing by K, divided by the interest rate K, and hit enter. There you see that the future value of this annuity is $3,183.60. Okay. Now we're going to look at getting the present value. Similarly, we have our inputs, 6%. Number of periods is going to be 3. Payments are $1,000. And we're being asked what the present value, or what we would have to pay in order to receive this annuity, would be. So our future value is going to be 0. And the type, again, is critically 0 for end of period payments. Hitting PV, we have rate, number of periods, 3 equal payments with no value in the future, and payments are coming at the end of the period. What is it worth today? Well, as you can guess, with 3 payments of $1,000 each, it's going to be something like $3,000. Because it's the present value, it should be less. There you go. The present value is $2,673.01. Now we're going to calculate the present value of this annuity using a formula, and we're going to have to be careful to get our order of operation correct. So we're going to enter it in the cell J12 using the equal sign. And let's start by building from the inside out. I'm going to start by doing 1 over 1 plus k to the n. 1 divided by, open brackets, 1 plus the rate of interest, close brackets, to the rate of number of periods. Okay. As you can see, that function seems to have worked. Now we're going to do 1 minus that. So going back into the formula, we're going to do 1 minus this amount. Okay. Now we need to divide this whole portion in the numerator by k. So going back into the formula, we're going to put brackets around the start and the end. And we're going to divide it by the rate of interest. Notice that we currently have what looks to be the present value interest factor of 2.67. We multiply this times the payment. You can either multiply it by the payment at the start or the end. The payment is $1,000, where multiplication is star. And we hit enter. And we find that the present value of this annuity is $2,673.01. If you find that you've made a mistake and don't get that value, it is most likely because of the order of operation, which can be very tough with such a difficult formula, which is why the Excel function is so handy. Now let's look at finding the value of an annuity due, where payments come at the start of the period. Notice that we're going to set it up the same way. We're going to use the same inputs, and we're looking for the future value of an annuity due that pays $1,000 each year for 3 years, compounded at 6%. With an annuity due, the payments come at the start of the period, so we're going to receive $1,000 immediately in year 0, plus 2 more payments of $1,000. Okay, so using the function 6%, 3 periods, payments of $1,000. Again, even though we're receiving a payment in the first period, we're not paying anything to buy this annuity right now. So the present value is going to be 0. And here, critically, we have to put the number 1 so that Excel knows that this is a start of period. Equals future value, entering the different inputs in their correct order for this function, and hit enter. The future value is $3,374.62. Okay. If I had accidentally hit end of period instead of start of period and put a 0, look what happens to the value. It has fallen down to $3,183, which is the value of an ordinary annuity with these features. Notice that the future value of an annuity due is larger because of this growth rate of 1 plus k, or 1 plus the interest rate at the end of the formula. Okay, let's see if we can do this using the formula. So we're going to do equal sign. What I'm going to do is I'm going to start with the outside brackets here, 1 plus the interest rate. And why don't we just take 1 plus interest rate times the payment? It doesn't matter what order we do it. Okay. Now we want to multiply each of these by this internal piece here. So I'm going to do star, open brackets, and you could close the brackets if you want. Now we see that we've got to enter this piece here. Notice that we have a numerator and a denominator, so we're going to have to put this in one part and that in another. So I'm going inside my brackets. I'm going to open them up. I'm going to now look at what goes in the numerator, which is 1 plus k to the n minus 1. So I'm going to have another set of brackets. 1 plus interest rate, close brackets, raised to the power of n minus 1. Notice that I have this inside these red brackets, which is representing the numerator, and now I just need to go outside those brackets and divide this by the rate of interest, k. Okay, let's see. Have we got it? Yes, we do. You can see that because we got the brackets correct, we were able to get the correct future value. Okay. Let's do this one more time now for the present value. It should be relatively simple because you've done it several times. It's all question of practice. Notice that because we're looking at what the present value is, the future value is now going to be 0. And the type critically is going to be start of period 1. Okay, using the present value formula. I confess that as I filmed this, I messed up several times. I just didn't bother recording it for you. You can see here that the present value is going to be slightly larger than it was for an ordinary annuity. Look what happens if we change this from start of period to end of period. We add a 0. You can see that the value will be 2,673. Whereas with start of period 1, you can see it's 2,833. That is because of this factor at the end, 1 plus k. Okay, let's try this again. Equals, I'm going to try it from left to right. Payment times open bracket. So here I am, 1. Oh, this is going to be on the top, the numerator, so I'm going to actually open another bracket. 1 minus, and now I want to get this present value interest factor right here. So it's going to be another open bracket, 1 divided by, and another 1 plus k, close brackets, raised to the power of n. Now I need to close brackets again so that I have this piece here. And now I have to close brackets again, so I have the 1 minus. Now I am looking for the denominator, so I divide by k, which is the rate of interest, and I close the brackets again, and I need to multiply it by this last factor, so it's going to be multiplied times 1 plus k. So open brackets, 1 plus k. Very easy to mess up, and fortunately I did it correctly. That's it. Lots of practice. Keep trying, and as you can see, by using the formula as well as the built-in function, you can get the same answer.